The same phenomenon of bagging and sagging in garments at the same places can occur with garments made of woven fabric too. Therefore, the textile industry developed a standard test method for the measurement of stretch and growth of woven fabric in 1975. As with the standard test method ASTM D2594 for knitted fabric stretch and growth that utilizes benchmarks and the application of force, ASTM D3107, the test method for woven fabric stretch and growth properties, does likewise. ASTM D3107 was developed for woven fabrics made of stretch yarns or having some amount of stretch yarns in the fiber content of the fabric. However, the standard method allows it to be used for woven fabrics that do not contain stretch yarns, but the same force and time interval are used. The apparatus for testing woven stretch is a board that has sets of fixed clamps at the top, with the lower part of the board having mechanisms for allowing a test specimen to be locked into a fixed extension after weights or tension are applied. Whereas knitted fabric stretch specimens are made into a looped configuration, woven specimens are single-layer strips. 6 22-inch length by 2.5-inch width specimens are used. 3 for stretch and growth after application of a specified tension, and 3 for growth after stretching to a specified extension. Some woven fabrics have stretch yarns in only the warp or length fabric direction. Therefore, only 6 warp direction specimens are needed. If the fabric has stretch yarns in the filling or width direction, 6 additional specimens will need to be prepared. The long direction of a specimen should be parallel to the fabric direction that contains the stretch yarn. Each specimen is then raveled to a 2-inch width, taking approximately the same number of yarns from each side. The next step of specimen preparation involves turning up a 1.25-inch fold on one end of the specimen and sewing a line across the specimen 1 inch from the fold. Then, in the middle of the fold, a 0.375-inch notch is cut away, leaving an opening into which a dowel pin can be placed and onto which a tension weight can be applied to the specimen. While the specimens are flat, 10-inch benchmarks are placed in the middle section along the long dimension of each specimen. This represents the original distance on which the measurements of both the stretch and growth under a specified tension will be based. Some laboratories use a 20-inch benchmark length. The standard method allows for 2 tensions to be used, a 3 or 4 pound weight. The option of which weight to use is usually specified in a material performance specification that is likely to be based on the weight of the fabric. The test is performed by placing the non-sewn end of a specimen into the upper clamp of the stretch frame and locking it in place with a clamp. A dowel pin is inserted into the cutout notch on the lower edge of the specimen. Then the selected weight, either 3 or 4 pound, is placed on the dowel pin, supporting the weight by hand. The application and release of the weight, or tension, is cycled 3 times. After the 4th application of the weight, immediately, within 10 seconds, measure the distance between the benchmarks while the weight is applied to the specimen. The weight is left on the specimen for 30 minutes, at which time the distance between the benchmarks is measured again. Using these measured distances, the percent stretch under tension is calculated at 0 seconds and 30-minute intervals with this formula. To calculate the percent stretch under tension, immediately subtract the measured distance under tension from the original distance, 10 inches. Do it again after 30 minutes under tension. Then divide by the original distance, 10 inches, times 100. Once the stretch with tension distances are recorded, the weight is removed from the specimen. The test calls for remeasuring the distance between the benchmarks after 30 seconds, 30 minutes, 1 hour, and after 2 hours. These measurements allow for the calculation of growth after stretching to a specified extension. The formula for calculating percent growth after tension is to subtract the original benchmark distance from the distance measured at the 30-second, as well as 30-minute, 1 hour, and 2 hour intervals, then divide by the original distance and multiply the resultant number by 100. Test data for stretch and growth percentages are reported as average length and width to the nearest tenth of the percent. Testing for the fabric attribute of growth after stretching to a specified extension uses 3 specimens that are cut, raveled, and one edge sewn, as were the specimens for the stretch and growth by the applied tension test method. The distance between the lower edge of the top clamp to the 0 stretch mark section on the test frame is 20 inches. A specimen is locked in place in the upper clamp, and the distance to the sewn line on the folded end of the specimen is checked and adjusted if needed to ensure the starting distance to 20 inches. The extension used for this growth measurement is 85%. With new specimens, mount them into the top clamps of the stretch frame. Pull the specimen out to the 85% stretch distance and secure in place with a pin. Leave the specimen extended for 30 minutes. After 30 minutes, release the specimen and allow it to hang freely. Measure the distance between the clamp and sewn stitch line after 30 seconds, 30 minutes, 1 hour, and 2 hours. From these measurements, growth after extension to an 85% stretch extension can be calculated using the same formula for percent growth as the one used for percent growth after tension. So we can say that there are ways to judge stretch and growth, all to try to predict whether wearing apparel made of knitted or woven fabrics, with and without stretch yarns, will deliver the comfort and ease of movement consumers desire without clothing being unacceptable due to excessive bagging and sagging.